Alright, we're looking at modeling and solving one-step equations. And we're gonna first use algebra tiles to model equations. These things down here are the algebra tiles, and it's just a way to kind of get our heads around what an x might be. Kind of use an object to represent an x instead of just talking about a letter, right? We're gonna kind of add something to it. In the book, you'll see the positive x's as a green rectangle, this guy here. You'll see the red x's, or sorry, you'll see the ones as a red square. This x squared we're actually going to get to later. You're not going to use those right away. We might pull out the kits, and they'll be in the algebra tile kits that we use. So similarly, you won't use the negative x squared. When we're talking about negative x, the book is going to represent that just as a blank rectangle, and negative 1 as a blank 1. So when we put these together, when we make equations, when we model equations, we don't add symbols. There's no plus or minus kind of in the middle here. There's just blanks, right? We can show an equal sign, or sometimes we'll maybe kind of use a separate space for what's equal to what here, right? So in this case, we've got that negative x, and then we've got 4 positives. So we would call this plus 4. We could say that's a negative x, and that's positive 4. In this case, it's equal to negative 1. And that's all we're worried about in these first 4 examples, just what is being modeled here. So it would actually be very good to just pause and just check this out right now, see if you can do 2, 3, and 4, and then come back and take a look at what I've done. The next one here, this is that x. It would be green in your book, but it's that rectangle, it's that unknown thing, which we call x. In this case, we're showing it's equal to negative 5, right? 5 blank squares. Next, we introduce kind of a new thing here. We've got this going on. So this is 3 x's, right? And we've seen already when we write it like that, that means 3 times x, or 3 groups of x, right? If x was a pencil, we'd have 3 pencils. So we might be thinking about the cost of the pencil, and we're going to pay for 3 times the cost per pencil, right? 3 pencils, 3 times cost per pencil. We can also talk about that 3 as a coefficient. That's a word you're going to hear kicked around in this chapter, is that the number, so that 3, whoops, let me just highlight it for you here. This 3 in front of x means 3 times x means 3 groups of x, or it's thought of as a coefficient. It's referred to as a coefficient. In this case, that 3x is equal to negative 6, and I apologize, that should be a negative 3x. So negative 3 groups of x. Those are blanks, right? So they're negatives. The last one, we've just got 3, and it's equal to this thing. And now this would be a blank, and what they're trying to show here is that it's cut in half. So we took a blank x tile, which is a negative x, and we cut it in half. So we could show it like this, or negative x divided by 2, right? It's been cut in half, or 3 equals, you could also write it as negative 1/2 of x. So in this case, this 1/2, when it's in front of the x, kind of becomes the coefficient. It's actually valuable to think of the negative as part of the coefficient too, right? We have negative 3 groups of x, because we'll deal with that negative with the 3, right? The 3 is negative. So you can make sure you know how to model. We're going to move on. Now we're going to draw diagrams, so going the other way. So let me get out some green for our x's. Here's our x plus 5. The book is going to do positive 5 like this with reds. And then that's equal to 7. 1, 2, 3, 4, 5, 6, 7. And the next one, we've got 2x. Our coefficient is 2, so we're going to draw 2 of the x tiles, those x rectangles. In this case, they're equal to negative 8. So here's 1, 2, 3, 4, 5, 6, 7, 8. And actually, let me just redraw this, just so it's easier to solve this guy, because we're going to come back and solve them in a minute. Here's our 2x tiles. And yep, that'll work. And then in this last one we have again a positive x, and now we're taking away 3, and we don't write in the symbol, so we use -3 here instead of taking away 3. It's equal to positive 5, so the book would use reds, but they're also solids. You can just kind of fill yours in, shade yours in, right? There's 5. So we've drawn them. I actually want to look at how to solve these as well, because that's going to help us out. Our goal is always to figure out what x is, right? If we had if this was like currency, if this was money in the first one, and this x was maybe some funky bill we'd never seen before, here's our funky bill, plus 5 of these guys, 5 coins. If all of that was equal to 7 coins, we're trying to figure out how much the bill is. And you're probably looking at it thinking, oh yeah, that bill's 2 coins, right? It'd be equal to 2 coins. 2 plus the 5 gives us our 7 coins. Another way to think about it is to subtract all this, to take away all this. So we'll get rid of all this, right? So we kind of cross these guys out, we kind of cancel them out, get rid of them, and we're left with 2 on both sides, right? 2 coins is equal to 2 coins, or the bill on this side is equal to 2 coins. So we always want to kind of get the unknown thing by itself. In this case, we could show that we're going to subtract this 5 over here, or we could add in 0 pairs. And this is actually a more beneficial way to think about what's happening here, is we're adding in 0 pairs. So I did the same thing to both sides. I put 5 negatives on the left, and I put 5 negatives on the right. And now these all cancel, because I'm making zeros. That's 0, 0, 0, 0, 0. And we're left with this x equal to these 2. Right? In black, we added in 5 negatives on both sides. In black, we added in negatives, or we subtracted 5 on both sides, and we're left with -2. And you could also show it like this. We're going to take away that 5, and we have to do it to both sides. So this cancels. We got nothing left over there, and x after that step is equal to 2. So that's what makes this a one-step equation, is we took all this out on this side, took it all out on this side, we did one step, the same step on both sides, subtracted 5 on both sides, we got our unknown by itself. In this case, what I was in number 6 here, what I was trying to show visually is that because we have 2 x's, our step is that we're actually going to divide by 2. So we're going to break this up into groups. Here's a group and here's a group. So each x is equal to -4. Right? When we divide by 2, that cancels. We've got x by itself. -8 divided by 2 equals -4. So that's how we solve that one. The last one here, we've got -3 on this side. So this is where those 0 pairs are even more helpful. We're going to make 0 pairs. And if we're adding 3 on that side, we have to add 3 on this side. So what we have left visually in our diagram is that this x is equal to 1, 2, 3, 4, 5, 6, 7, 8. And we could show it like this. We're adding 3 on this side, so we have to do the same to both sides. We've got to keep it equal. X equals 8. Alright? So pause and write in what just happened there. Make sure you understand what just happened there for 5, 6, and 7. Then take a look at what's next. And we're talking about opposite operations now. It says an opposite operation undoes another operation. Examples of operations are subtraction and addition, multiplication and division. You sometimes hear opposite operations called inverse operations. So just some language for you there. But now if we look back at 5, 6, and 7, we had x plus 5, and we took away the 5 to get x by itself. We had 2 times x, and we divided by 2 to get x by itself. We had x minus 3, and we added 3 to get x by itself. So in each case, we're using opposite operations to get x by itself. And that's our rule. Use opposite operations to get x by itself. That's what we're going to do every time. Use opposite operations to get x by itself. Make sure you've written that down, and then we'll look at a few. Here we have our variable divided by -5, so we're going to multiply by -5. If we do that on that side, we have to do it on both sides. So those cancel, and we get d equals -60. Or our step there in the middle, and you're making sure you have that step, was 12 times -5. So Let me just erase this and put it below, right? That was the... Hang on, there you go. That was the math that just happened. That's what we just did, and we got d equals negative 60. On this side, we have 3 times x. We have 3 groups of x. So our opposite operation is we're dividing by 3. X equals negative 15 divided by 3. So x equals negative 5. I'll just put some boxes around our answers so you can see them. This last one, we have negative 4 times a. So our opposite operation would be to divide by 4. And I'm canceling this because I have a by itself on the right, and I have negative 20 divided by negative 4 on the left, I'm sorry. And we're left with 5 equals a. Negative divided by a negative is a positive. Alright, take a look at the blog for your assignment, and good luck, you guys. Make sure you have all of that written in, and make sure you understand it. Go back and watch it again, check it out again, to see the steps if you don't understand the math that's happening. That rule is what's all about, right? Opposite operations. Thanks, guys.